Hello, in this video we're going to work through this problem here. So we're going to find the angle of elevation of the sun when a tree 10 meters tall casts a shadow 20 meters long. So with this problem it's really important that you understand the term angle of elevation. And I'm also going to talk about the term angle of depression. So whenever we see the word angle of elevation or angle of depression, what we want to do is draw a horizontal line, and depending on which we're dealing with, elevation or depression, we do the following. An angle of elevation is an angle which goes up from the horizontal. So if I talk about an angle of elevation of say 20 degrees, let's pretend, this would be the angle of elevation of 20 degrees measured from the horizontal. If I was to talk about an angle of depression of 20 degrees, again I would go from the horizontal and I would go down 20 degrees. That's an angle of depression. So angle of depression angle of elevation. Okay, so here we want to find the angle of elevation of the sun when a tree 10 meters tall casts a shadow 20 meters long. So whenever I have a problem like this, I typically draw the ground. So here's the ground, and now I'm going to draw my tree. Here's my tree, and my tree is 10 meters tall. Now notice I don't draw a fancy tree here. A line is perfectly acceptable because it makes it easier to notate my diagram. So if the shadow is 20 meters long, we can put a point here, and that's 20 meters. I have to think about where's the sun. Well, if the shadow is cast here, that means the sun is somewhere up here. So if I draw the sun up here, there's the sun. What happens is a sunbeam comes down. Here's the sunbeam, or ray of sun. And it kind of extends to there. So let's just clean up this diagram a little. So there. So this is my tree, 10 meters. This is the shadow it casts, and the angle of elevation would be the angle measured right here. Let's call that theta. So I look at theta, and I look at what I'm given, and I know this is a right triangle, so 10 meters is the opposite, 20 meters is the adjacent, so I know that I'll use the tan ratio. So tan of theta is equal to 10 over 20, which is equal to 1 over 2. Reducing that fraction is always useful. So therefore, theta is equal to tan inverse 1/2. So theta is approximately equal to tan inverse 1 divided by 2. I get about 26.565 degrees. And there we go. Therefore, the angle of elevation is about 26.565 degrees. So again, the big takeaways from this question is the definition of this term angle of elevation. And we can tie into that the definition of angle of depression. So anytime we see those terms, we think of a horizontal, and an angle of elevation goes up from the horizontal, whereas an angle of depression goes down from the horizontal. Always draw a nice diagram and make it large, because the larger your diagram is, the easier it is to add information to that diagram, which will help communicate your idea and find a solution. I hope that video helped. As always, please feel free to ask questions.